Okay, so what are we going to talk about this evening? We're going to talk about the art of Java type patterns. And in terms of the idea here, if we look at how Java has changed quite a lot over the last few years, more so than we've seen really in the previous, let's say, even 10 years before that. Because if you think back to, what was it, 2017, 2018, Oracle decided that they would switch from having 2, 3, even 4 years between releases of Java to now just having 6 months between every release. So we get a release twice a year, March and September. And I've got to say, I think this is working really, really well. We're seeing a lot of new features being added to the language, to the platform, in a way that's much faster than we've ever seen before. We're also seeing that this is being done in a nicely controlled way with the introduction of preview features and incubator modules. So that what's happening there is that features are being added so that people can try them out rather than making them part of the standard straight away. People try them out. If changes are needed, then we still have the opportunity to do that before it becomes a part of the formal standard. And we've seen that work in a couple of different ways, and I'll highlight some of that as we go through. So like I say, lots of new features. Most of the language stuff is covered by Project Amber. It's a sort of umbrella project that covers, as it says here, to explore and incubate smaller productivity-oriented Java language features. And with the preview idea, all of those language features are now being introduced as a preview. It goes through normally 2, maybe 3 rounds of preview, and then it becomes part of the standard. And again, the way that people like Brian Gertz and Mark Reinhold are making the changes to the platform is being done in a nicely organized way so that many of the features will work separately, but they also work together. And again, we'll see that as we go through. Okay, so let's talk about pattern matching in Java. Pattern matching in Java has existed really in one form or another since JDK 1.4, because JDK 1.4 introduced the java.util.regex package. And if we look at that, we can see that we can do something like this, where we can create a pattern for a specific regular expression. We can say A star B, meaning A followed by 0 or more characters followed by a B. Then we can create a matcher for that for a particular string, and then we can determine whether the pattern matches against that string and then return a Boolean. Or we could do that in a single line. Great. Now, I actually did this presentation as a webinar a little while ago, and at this point, 2 people dropped out because they didn't wait for me to put the next bit up, which is, this is not what we're here to talk about. I was really impressed that 2 people actually at that point go, he's going to talk about APIs? No, and they dropped out. So this is not what we're here to talk about. We're here to talk about pattern matching in the language, not in the APIs. Right, fundamentals of pattern matching. Pattern matching as a language construct has been around for a long time. You can go all the way back to the 1960s, and you can look at languages like Haskell, you can look at languages like Awk. Anybody here used Awk? Okay, good. Goodly number of people have used Awk, one of my favorite sort of scripting tools that I used when I did Unix. So it's been around for a long time. What do we mean by a pattern? Well, a pattern consists of 2 things in the sense of a language feature. What we have is the idea of a match predicate. And a match predicate is essentially looking at whether we can match on a particular pattern for a given target. So it's predicate, meaning it equates to a Boolean result. It's either true or it's false. We either match against the pattern or we don't. We then have 1 or more pattern variables associated with that. And if we match on the pattern predicate, then we will conditionally extract something from that in terms of the target. And we'll see how this all works as we go through. But essentially, in this case, a pattern has 2 parts. It has the predicate, which determines if we match something, and then we've got some variables that we make available if we do match. There are a number of different pattern types. First of those is a constant pattern, and we've already seen this in Java right from the very beginning, because if you look at the switch statement, that uses constant patterns. You've got case 1, case 2, case 3. So the pattern that we're matching against there is the value 1, 2, or 3. Obviously, because it is a constant, there is no variable involved. It's a constant, so it can't vary. We don't bother with having a variable associated with it, but we're matching against a particular pattern, which is a constant. So we can think about that. When we look more at the new features that have been added to Java in the last few releases, what we're primarily dealing with is type patterns. We match on a given type in the Java language. Again, we'll see lots of examples of this and understand how it is that we can use different types and use those in different ways for our pattern matching. We can also have other types of pattern. So we can have a deconstruction pattern. I'll show you some examples of that later on, which is where what we're doing is not just matching against a particular type, but then we're also extracting things from within the type, deconstructing it and making those things available as the pattern variables. We have a var pattern type, and again, this is sort of related to the introduction in JDK 10 of local variable type inference. Introduction of the var keyword for local variables. We can also potentially use that in our pattern matching, where we're not worried about what the type is that we're actually looking for. We'll let the compiler figure that out for us, so that the compiler will infer the type. Still very much statically typed. We're not moving into any kind of dynamic typing here, but it allows us to avoid having to figure it out ourselves, and we just say var. And then the last one that we'll talk about today is the any pattern. Similar to var, because it matches against anything, but in this case, what we're saying is that we don't care about the specific thing that we're matching against. Now, that might seem a bit counterintuitive. Why are we matching against it if we don't care what it is? But again, I will show you a good example of why that is actually very important, why it's very useful. Right, now before we get into pattern matching, we need to talk about a couple of things that have been introduced into Java as part of these changes over the last few years, which relate very strongly to how pattern matching is used when we get to see that. So the first of those is switch expressions. If you look at Java right from the very beginning, we had the switch statement. And the syntax of the switch statement was taken directly from the C programming language. Great. C programmers understood how to use that. If they wanted to move to use Java, then it was very familiar for them. That's all well and good, but unfortunately, they also took directly all the drawbacks of the switch statement that they had in the C programming language. One of those things is that when you create a switch statement, you have a block of cases, and then you do something in your case statements, and you have to remember to put a break statement in. Because if you don't put a break statement in, the logic is that you will drop through into the next set of cases and do whatever is associated with that. Hands up, anybody who has ever forgotten to put a break statement in a switch block? Yes, I know I have done that on more than one occasion. And this can lead to some very difficult to debug code, because you think to yourself, it cannot possibly do that. It is illogical. It must not do that. And then you go through it and you go, oh, I forgot to put the break statement in, so it's dropping through and generating a different value. So that's one of the things that is a bit of a drawback. The other is that sometimes the scoping of local variables can be counterintuitive, so we need to think about that. Let's look at an example of how we would use the switch statement at the moment, before switch expressions. This is a very common idiom for using switch statements. What you're doing is you're switching on one variable, and then you're assigning a value to another variable. Here, I'm switching on the day of the week, and then I want to assign a value to the number of letters in the name of that day. Very simple code. As you can see, we've got switch on day, case Monday, case Friday, case Sunday. Number of letters is 6. And then we have to remember to put the break statement in, because if we don't, we could get a value of 7 or 8 or even 9. The other problem we have here is in terms of difficult to, or unreliable code, I should say, is that we have to explicitly assign a value to the number of letters in each of those case blocks. And again, if we forget to do that, because I'm using an instance field rather than local variable, the compiler will not complain. The compiler will just say, oh, you want a default value for number of letters, we'll make it 0, and everything will work quite happily and compile. If it was a local variable, at least you might get a compiler error because you haven't assigned a value. So these are the drawbacks that we have with using the switch statement. What we can now do, since JDK 12, is use a switch expression. Switch statement says execute a set of instructions, but it doesn't generate a result. An expression executes a set of statements and then generates a result that we can assign to a variable. This is good because it immediately solves one of the problems that we had. We make the assignment to a number of letters once, and that way we can see that we're doing that, and the compiler can verify that each of those cases has a value that's being returned. So it will determine that and give us an error if we forget to do something there. You can also see that in terms of the syntax, we've dropped the idea of having the break because we don't need it anymore. We're returning a value. The other thing, if you look at this code, is you'll notice it's quite a lot shorter than the code we had on the previous slide. The reason for this is that the engineers who developed this particular feature scoured the internet and they found this little known thing which enabled them to shorten this code. It's called a comma-separated list. What we can now do is put several things on the same line. I find it difficult to believe that it took over 25 years for somebody to figure that out. But here we go. So now we have case Monday, comma, Friday, comma, Sunday. That is probably the biggest contribution to Java in the last few years, in my opinion. So the other thing they did was borrow the lambda syntax. So we have the arrow operator, and the right-hand side of the arrow operator is the value that we return from the expression, or in the case of the default, we can throw an exception to indicate that something didn't work out. This is all really good because it shortens the code, eliminates a lot of boilerplate, eliminates a lot of potential errors, but doesn't lose any readability. All very good. But the important thing about this is that switch expressions must be complete or exhaustive. I will come back to what we mean by this later on when we talk about pattern matching. The other thing we need to talk about before we get on to the real pattern matching stuff is the idea of algebraic data types in Java. There are two things to talk about here. First is the fact that we often use simple data classes in Java. Java is an object-oriented language, so we have encapsulation of state and behavior. If I want to create a simple data class that holds two values, I end up doing something like this. I've got a class that I want to hold two X and Y components, and I'll call it point. To do that, I obviously create a new class. I then have to have two instance fields, which I define as double X and double Y. I'll make them private because I'm encapsulating them. I'll also mark them as final to be good. Then I need a constructor, which I pass two values into, X and Y. I have to explicitly assign the values from the parameters to the instance fields, and then I need accessor methods to get the values from that object. So I've got double X and double Y, just returns X and returns Y. That is 14 lines of code to create a tuple. And I always thought that it would be really good if, given that there are 4,500 classes in the standard class libraries in JDK 8, there's actually more than that now, but 4,500 classes in JDK 8, why couldn't we have a tuple? And I did ask Brian Gertz about this, and I said, why can't we have a tuple? And he said, well, yes, we could give you a tuple, but then you'd want a triple, and you'd want a quadruple, and where would we stop? So they came up with a much better solution. The solution to this problem is records. Introduced in JDK 14, this is essentially a data type in Java, which means you don't have to provide all of the extra boilerplate code. In this particular example, it is really just syntactic sugar to the previous slide. The compiler will generate all of the code that we saw previously, but we only need to write one line. So we define a record, we call it point, we use the same syntax that we would use for the constructor, and we define the values that we want to store in that record as a double X and a double Y. Everything else comes from the compiler. Now, a record is just a special form of class, same way enumeration is a special form of class. So we can have a body, but in this case, we're not putting anything in it. If we want to, we can make records generic. It's just a special form of class. We could include a generic type parameter T, and then we can store objects of type T in our record. That works quite happily. If we want to, we can add more functionality to our record, but there are restrictions on what we can do. First of those is that we can't add any instance fields that aren't defined in the record description. So we couldn't add another instance field, say Z, which isn't in the point definition. In this case, we've got a circle, we have one value we're storing, which is a radius. We can have static instance fields. We can add pi as a fixed value, and then we can add other methods to include new behavior, in this case, to calculate the area of our circle. So we can do that, and we can add things if we want to. But really, the idea behind records is simple data types for moving things around. A few things about detail, a few extra details about records. First is that all records will inherit directly from java.lang.record. Because we have single inheritance in Java, that means that you can't have a record which extends another class. So it already extends java.lang.record, so you can't extend a record in a different way. However, if you want to implement interfaces, you can do that. So you can add as many interfaces as you want, implement the methods, and that works quite happily as well. Records are also implicitly final. You cannot extend a record further, you can't subclass it, that won't work. If you want to, you can mark them as final, but it doesn't make any difference because the compiler will just assume that they are final anyway. Records do not follow the Java bean pattern, and this was something that there was a lot of discussion about in terms of the development of records. A lot of people are used to the idea that if you have a data type that you want to use, you use the bean pattern, which means the name of the accessor method is getX or getY. That's logical because if you have a bean which can also have values that can be changed, so they're not final, then you have the equivalent mutator method, setX and setY. So you want different names for them, so you've got setters and getters. Because records are shallowly final, meaning that the values that you store in the record are final, even though obviously if they're records, if they're objects, then you can change the values inside those objects. But from the point of view of the values you store in the record, they are final. So you don't have a mutator method. There is no set X or set Y, it's fixed. So the decision was made to give the name of those accessor methods just the name of the variable. This did cause a few problems initially because things like Spring Boot, when they were using objects, moving them around as data types in there, they were expecting the bean pattern, so they were expecting to use getX and getY. They have subsequently changed the way things work, so they do support records very nicely. And as somebody pointed out to me, there is actually a way around this, because what you do is you simply call your variables getX and getY. It's if you must. It's not really to be recommended, but it does solve the problem. Sure. Because then it's not true encapsulation. So if you make it public, then it's not following the rules of encapsulation. And so the idea was to make the things internal. So that was really the idea behind that. The other thing to talk about before we get onto the real type pattern types stuff is around inheritance. So we have inheritance in Java. Again, it's object oriented, and we can create a type hierarchy with a shape as a class and then 3 subclasses of that: triangle, square, and pentagon. That's all very good, except we have no real control over who can subclass our shape class. Only thing that we could do is mark it as final, which means that nobody can inherit. Really, that's an all or nothing. Either anybody can inherit from it or nobody can inherit from it. What they did in JDK 15 was introduce the idea of sealed classes. And sealed classes now says that you can define your type hierarchy, but you can also restrict to a set of classes the ones that can inherit from, in this case, shape. To do that, we now have a new modifier for our class. So we have public sealed class, shape, and then we add a permits clause after that, which says that we're permitting triangle, square, and pentagon to be subclasses of shape. If somebody comes along and says, oh, I really like that shape class, I want to use it to make a circle, the compiler will say, circle is not listed in the permits clause of the definition of shape, therefore you cannot subclass it and it won't allow you to do that. The other thing about sealed classes is inheritance for the subclasses. And all of the subclasses of a sealed class must explicitly state their inheritance capabilities. And there are three ways of doing that. The first is that we can continue to make that a sealed class, and we can provide another permits clause with further subclasses of that. In this example here, we're saying public sealed class triangle permits equilateral and isosceles, and it extends shape. So that means that we've then got a further two subclasses that we can create from that. The second thing that we could do is to make that subclass final, meaning nobody can further subclass from there. So square is now final, nobody can inherit from square. And then the third thing that we can do is to effectively unseal that class. And we can tell the compiler that in this case, pentagon is no longer going to be sealed and anybody can inherit from it. Again, this is one of those things where we see this hyphenated keyword. You can't believe the amount of discussion that went on about whether Java should use hyphenated keywords. But the decision was that yes, we should, because in improving the language over time, it gives us the option to have more possibilities for keywords there. But it is also important to understand that in terms of that being a keyword, it's a contextual keyword, which means it only behaves as a keyword in that specific place. There's a very good reason for that, because again, as somebody pointed out to me, if you were to create two variables called non and sealed as integers, you could then say sealed equals non-sealed, because in that case, it's not a keyword, it's saying non minus sealed. So you're using the subtraction operation and everything compiles quite happily. So you can't use non-sealed as a keyword everywhere. Oh.
Is that also the case with like sealed and permits?
Exactly, yes. Yeah, so you don't have to worry about, if you've used sealed as a variable name, you don't suddenly have to go and change all of your code to use. Yep.
And then the default, if you didn't have any of those sealed, but non-sealed, is it a compile error?
That would be a compiler error. You have to explicitly state the inheritance capabilities. If you leave it out, the compiler will complain. Right, so let's move on to what we have in terms of current pattern matching. By current, I mean up to JDK 18, which is the release that we have at the moment. First thing that we need to look at is how this can be applied to the instance of operator. Once again, because Java is object-oriented, we have the idea of polymorphism. We can view an object as any of the types which it actually is, meaning the specific type that it is, any of the super types of that, plus any of the interfaces that any of those types implement. If we want to determine exactly what type we have or whether it is of a given type, then we use the instance of operator. And we've all done this, so we know exactly what we're doing here. And what we do is we say if obj instance of string. But then within the true branch there, we have to always perform an explicit cast with an assignment. And that's really just, one extra line of code. Why should we have to do this? If the compiler or if the code has verified that we do have an instance of string, why do we have to do this explicit cast and create a new variable of type string? Why can't we just use it as a string? So the idea in JDK 14 was the introduction of pattern matching for instance of. What we do now is we say if obj instance of string, and going right back to the beginning of the presentation, I said the pattern consisted of two things, the pattern predicate or the match predicate, and then the pattern variables. In this case, the predicate is obj instance of string. So it evaluates to a Boolean, so we know that we have a predicate. If it is of type string, then the pattern variable is now S, meaning that the compiler will, again, in effect, fill in the explicit cast with the assignment for us. So S is then valid for use as a string. In terms of the scope of that, because we have to be able to use it within the true branch, then we can obviously use S quite happily. We can use the length of that. But if we look at the false branch, then because we don't have a string, the scope of S will not be valid, so we couldn't use S, and the compiler would reject that. We can be a little bit more sophisticated about how we do this, and we could say if obj instance of string S, and then use an AND operator and say s.length greater than 0. This will work quite happily because we know the way that the AND operator works is that we will always evaluate the left-hand side of the operator, and only if it evaluates to true will we evaluate the right-hand side of the operator. If the left-hand side evaluates to true, the scope of S is valid, so when we try to do s.length, since S is valid, we can call the length method on it and it will compile and work quite happily. However, if we try and use the OR operator, that won't work, because once again, we know that in the case of the OR operator, we would always evaluate the left-hand side, but we would only evaluate the right-hand side if that evaluated to false. So S wouldn't be, or obj wouldn't be a string, S, the scope, wouldn't be valid, therefore we couldn't test on s.length on the right-hand side. So that would give us a compiler error. When it comes to the scope of the pattern variable, it isn't necessarily always obvious. We could do something like this. We could say, okay, we're doing something with an object reference and we're going to test O instance of string S, but let's invert the test. So we'll do if not O instance of string S, meaning that if it's not a string, then we'll return from the method. And that means that after that, the scope of S is still valid because we're effectively in the true branch of the if statement, even though we're not in the if statement. So S is still valid at that point. We could then print out the length. We could have several hundred lines of code, and then we can still use S lower down because its scope is still valid. Yeah.
So I really like this feature. I've been used to it for a while in TypeScript, but there they refer to it as things like type reduction, where you're type narrowing, where you're taking strongly or type that can add multiple processes instance of, let's say it's going to be this way. Here we're referring to it as pattern matching. Is it essentially the similar thing, but we're just calling it two different ways, or is Java thinking about it different than?
I think it's effectively the same thing. It's just that we refer to it because we're using pattern matching in the case of the syntax here, where we have the match predicate and then we have the type variables. So because it is technically using pattern matching, that's why we refer to it in that way. But it sounds like it's exactly the same thing in terms of what you are able to do with that, but we just refer to it in a different way. Okay. So what this brings us to is how we do scoping for binding variables. And if you look at local variables that we use all the time, we know that the scope of a local variable is from where it's declared until the end of the block in which it's declared. Meaning if we've got just a block of code, wherever you declare your variable, it's up to the end of that block, or if you've got a for loop or a while loop, then it's within that block, or if you've even got a method, it's within that method. The other thing is that local variables are subject to definite assignment, meaning that you as a programmer have to make sure that some value is assigned to that variable. Otherwise, the compiler will complain. It's not like instance fields that have default values, local variables have to be assigned something in the code. So binding variables work in a similar way, but slightly different. So binding variables also subject to definite assignment, meaning that they have to have a value assigned to them. But the scope of the binding variable is the set of places where it would definitely be assigned. So that's where we come to the true branch. So we know in the true branch, it is definitely assigned a value because it is of that type, versus the false branch, it is not of that type, so it doesn't have a definitely assigned value. Similarly, if we invert the test and we do a return, we know that the places where it will definitely have a value is after we've done the return, or we haven't done the return in effect. So the scoping is a little bit different to the way things work for local variables. And this allows us to do some things which are quite useful. We can do something like this. We could have a set of if-else statements. And now we can say if O instance of integer, and we'll use a type variable num and have some code. And then we could also say else if O instance of float and reuse num as a variable name. Similarly, we could have another one, O instance of long, and we can reuse num. That's really good because if we were using local variable scoping rules for this, then we'd have to have up 3 different variable names, which just gets messy. So now, because we're using flow scoping for this, we only need to use that we can use the same variable name in all 3 places, and it works quite without any problem. Right, here's a puzzle for you. I always like doing this, and this is much better when I can do it in person because I can get people to put their hands up. So I have a piece of code here. I create an object, new object, and I'll assign it to a variable called s. Then I'm going to say if s instance of string s. And if it is, then I'll print out string of length, s.length. Otherwise, I'll print out no string. So who here thinks that this code will compile? Okay, 1, 2, a few people. Okay. Who thinks this code will not compile? Shouldn't compile. I like that. Yes, that's a really good answer. That's more precise, more computer science. Yes. Okay. Who thinks it will both compile and not compile? How? Yes, which is where we get into quantum superposition of code, which is just impossible. And the answer is it will both compile and not compile. Okay, what do I mean by that? If you take this code and you put it in a file and you run Java-C on it, you will get a compiler error. Quite logically, because the compiler will complain that because you have already used s as the variable name of the object, you can't reuse s as the variable name of your pattern variable. So you think, okay, that's great. I put it into a file, it won't compile. However, sorry?
S is not a string. So it's never hit that in a statement.
No, so the interesting thing is that if you put this code into JShell, it will work. And so I actually literally cut and pasted this from JShell, and I checked it with JDK 18. It's not quite the latest version because there's an 18.0.2 that just came out today, but I'm pretty sure it still does the same thing. If you run it on JShell, it will not complain, and it will give you the result you'd expect, which is no string. I have no idea why this works in JShell, but doesn't work with the compiler. Because as far as my understanding of how this worked is that JShell is just built on top of Java-C. So it should just be using Java-C and should give you the same error message. And I did this presentation a couple of months ago, and I had somebody in the audience who's a guy called Remy Forax, and I don't know if you've heard of him, but he's one of the people who does a lot of work on OpenJDK and the development of these new features. He's on the Project Amber sort of team. And he looked at it and he goes, no, that shouldn't happen. He said, that's definitely a bug. So I don't know, but it was just kind of interesting when I found that. Right, next thing that we can use pattern matching for at the moment is pattern matching for switch. Now, again, if you look at the switch statement and even the switch expression that we've seen, you are restricted up until now on what you can switch on. You can have integral values, numbers, you can have strings, and you can have enumerations. What has happened now is that we have expanded that so that you can also now switch on a type. So you can do something like this. You can say type tester, pass in an object reference, and then we can do a switch on O, and we can have different cases for different types. The first one we can include is case null. That makes sense because this actually ties up a little problem that existed really right from the very beginning with the switch statement. Because what you would have had to do before is you'd normally have a test before you went into the switch to see if you had a null pointer. And if you did, you had to handle it explicitly. What we really want to do is include that into the switch, because switch is really just a multiple if then else. So now we can, and so we can put as the first one, we can have a case null. And again, because null is null, so there is no variable involved there. There is no point in having a variable associated with that. So you can print out we've got a null type. Then we can have pattern matching. So we have the case string, which is our match predicate to see whether we match against that. And S is our pattern variable. On the right-hand side of the arrow operator, obviously we can make use of S and we can print out the string. Similarly for color, we can have a type variable C, and we can say print out the RGB values of that, calling the appropriate method. Now, primitives in Java are not types in the sense of the type system, but arrays of primitives are. So we can have a case for an array of primitive ints, and we can call that IA, and then on the right-hand side, we can also print out the length of that because we can call the necessary code there. And of course, we can put in the default there as well if we want to. Oh.
So the ability of it to handle null, is that only with this new variation of syntax of the switch statement, or would they retrofit that to the standard switch?
I'm glad you asked that, because the very next slide will answer that question. Right, null is special and a bit complicated. So you can include case null in all switch statements and expressions. But in order to retrofit it to earlier code, what the compiler will do is it will insert, if you don't put one there explicitly, it will insert one for you. So if we take the example we had before, where we say switch on O, we've got a case string, case color, case int array, and a default, what the compiler will actually compile in that case is with a case null, there's the first one, throwing a null pointer exception. So the behavior will be identical to the way the code worked before, but from a syntactic point of view, what's really happening is it's inserting the null for you and giving you the same behavior. But the good thing is that we don't have to do that. What we could do is we could say, right, we want to deal with null and anything that we don't catch with our case statements in the same way. And because we can now have comma separated lists of things on our case, actually there should be a case in there as well. Yes, that's a typo. There should be a case null. No, there shouldn't be a case null there. No, I'm wrong. So that is right. Ignore what I just said. That is right. So you can have null, comma, default, and then you can print out bad value or bad input for that. So you can catch both the null and anything else in the same statement. Completeness. So I mentioned this when I talked about the idea of a switch expression at the beginning. What we have to deal with in terms of switch statements and all switch expressions is that they must be exhaustive or complete, meaning that we have to deal with all potential values. As an example, let's again take our type tester, we pass in something of type object, then we can have switch on O, but this time we're just going to have two cases, string S and integer I. That's all good, so long as we have a string or an integer. If we have anything else, what's going to happen? Technically, you could argue that because there isn't a case for whatever you passed in there, you simply ignore it and move on to whatever is the next statement. But the designers of the feature said, no, we don't want to do that because that could potentially introduce a lot of bugs. So we need to make sure that every possible value is dealt with. Simple way to deal with that, as we all know, is simply to say add a default statement so that anything that isn't a string or an integer will be handled by that. Because obviously there is an infinite number of types that we could have, so we could end up with an infinite number of cases. However, that doesn't mean that we have to have a default for every switch statement using type pattern matching, because we can use sealed types. So if you think back to the example I gave you earlier where we had a shape which had 3 subclasses, triangle, square, and pentagon. Now what we can do is we can change our type tester and we can say, let's type test on a shape reference. Then we'll do switch on shape and we'll say case triangle T is triangle, case square, case pentagon, case shape. In that particular example, we have dealt with all possible types. So there are no other types that could exist there. Obviously, in the case of our triangle, we did have 2 further subtypes, isosceles and equilateral. But again, polymorphism means that because both of those types are triangles, they will be caught by the triangle case here, meaning that we're still complete. So there is nothing that we wouldn't catch in terms of a shape using this particular switch expression. Actually, switch statement, I should say, not expression. The other thing we can do with the pattern matching on switch is we can also use guarded patterns. Again, this comes back to what I was showing you earlier in terms of instance of. Now what we can do is we can say switch on shape, and then the first case we'll have is case triangle T, and then we'll add the AND operator and say also if t.area is greater than 25, then we'll print out we've got a big triangle. Then in order to be complete or exhaustive, we must also have a case for just a triangle on its own. Because if we had a triangle that was less than 25 and we didn't have a triangle case on its own, then we wouldn't catch all possibilities. So you have a triangle T, print out it's a small triangle, so the compiler's happy, everything is still dealt with. So in this case, in JDK 18, the syntax for that is to use the AND operator, so the double ampersand. In JDK 19, they have changed the syntax slightly. This is one of those things with preview features, meaning that they can make changes before it becomes final. Now what they're going to do is they're going to say, when case triangle T when t.area is greater than 25. Once again, you wouldn't believe the amount of discussion that went on about should we use when or should we use if? Because you could logically say, you know, case triangle T if t.area is greater than 25. But the thought from the people, you know, developers, was that overloading the if operator into this particular position wasn't going to be very sensible. So they used when instead. Because the problem you could have is that you could say case triangle T if t.area greater than 25 arrow if something else. So it would then get a bit confusing. So I think it's better to use when. To be honest, I would use and. It seemed quite logical before, but there you go. So now we have when. Pattern dominance is another thing that's quite important. So the thing here is that the less specific cases must not hide the more specific cases. If we take our shape example again and change the order of the cases, and we put shape at the beginning, then that's not going to work, because again, polymorphism means that everything in that case in that example is a shape. So shape will always match, and that means that the triangle T, square S, pentagon P are unreachable. There is no logic in having those there because everything will match on shape. So the compiler will complain, it will say shape will always match first, unreachable code, and you have to then reorder things. That also applies to guarded patterns, because if you reverse the order of your guarded pattern and say triangle T first, everything that is a triangle will match against triangle. You'll never get to the point where you're also testing to see if the area is greater than 25. So the compiler will reject that one as well. And again, doesn't always mean that the guarded pattern must go first, because if you really wanted to be odd, you could do something like this. You could say case triangle T when true, and that would hide the triangle T on its own underneath. Now, I don't think anybody would do that because that doesn't make any sense, but you could have a situation where the compiler could determine that whatever thing you were testing would always equate to true. If you were calling something that always equated to true, then yes. Yeah, so if you said less than 25 and greater than 25, but 25 wasn't caught, then yes, the compiler would still complain about that. Yes, it's smart enough to figure that out. So yes, you need to be careful about the pattern dominance ordering. So that one would be rejected. So essentially what the specification says, it is a compile time error for a label in a switch block to be dominated by an earlier label in that switch block. So that just makes things quite clear. Okay, so that's what we can do up to JDK 18. What about things that we can do beyond JDK 18? Some of this is things that are planned and are actually in the roadmap. Some of these things are just ideas. Now, we can do pattern matching with instance of. We've already seen that. And we can do things with records. So we could do something like this, where we have our record point X and Y. Good. And we could very logically have a method that takes an object, and we can say if O instance of point P. So we're doing pattern matching. Our instance of works quite happily. We've got a pattern variable P. Then if we want to calculate the hypotenuse of this, we can use Pythagoras. We can extract the values of P dot X, P dot Y, and then calculate X squared plus Y squared square rooted. Good. But we can do better than this, because we know that records are nice objects. So now what we can have, or we will have at some point in the future, is pattern matching for records. And this is the idea of a deconstruction pattern, where we're still looking for a pattern in terms of the type, but we're going to extract things from it automatically. And again, since record is just a special form of class, you can actually make this work with normal classes as well. But we're doing it with records here. Now what we can do is we can say if O instance of point, and we give the definition of point, so we've got double X and double Y, then within the body of that, we can simply reference X and Y as the variables of that point record, and we don't have to do the explicit extraction of the values. So we'll let the compiler do that, and it means that the scope of X and Y are valid, and we can use those as referencing what's stored in that record. Now, the nice thing is patterns are also composable. Let's make our example a little bit more complicated. Let's introduce an interface called rectangle, and we'll have our record point, which we've seen before. We'll also add an enumeration color, red, green, blue, and then we're going to have a couple of records. One's going to be the color point, which takes a point and a color, and then we'll have a color rectangle, which takes a color point as the top left, color point as the bottom right, and we'll say that it implements a rectangle. Great. What we can now do is we can create a method which prints a color for a rectangle, and we can use our pattern matching on instance of. So we'll say, I should probably have called that R rather than S, thinking about it, but oh well. Rectangle S, and then we say if S instance of color rectangle, we'll use our record, pattern matching, and deconstruction. So we've got color point top left, color point bottom right. Then we can print out top left dot C, which gives us the color. However, we know that top left is a record as well, which means we can then have a record within a record. So we can say if S instance of color rectangle, color point, point P, color C, and then we'll call color point BR as the bottom right. Now we just point out C, or print out C. But we know that point is also a record. So we can compose a little bit further, and we could say, let's create a print top left X method, which takes a rectangle, we'll do the if s instance of, and now we have color rectangle, color point, point, double x, double y, color c, color point br, and print out x. So this is good and bad. So this is good because it means we can compose the patterns and we can get access to the individual variables that we want. But this is starting to get messy. How can we improve on that? Well, there's a couple of ways that we could do that. First is we could use the var pattern, where we're saying to ourselves, right, well, we know what we're dealing with here, but we don't want to have to explicitly state all of the types. So let's have the compiler do the type inference for us and have any pattern being matched. So now we can simplify things a bit and we can say color rectangle, color point, point, var x, var y, var c, var br. And that way everything kind of fits in nicely because we can just say, okay, they're vars, we don't care what they are. However, we could go even further than that and we could use the any pattern. Now this is complete speculation on my part. In fact, I didn't even come up with this idea. I saw somebody else has suggested it as a great idea. And it's not part of any JEP yet, although it is related to another JEP which hasn't been implemented. And there's a JEP called 302 on lambda leftovers. Now the idea there, if you look very carefully at what was introduced in JDK 9, one of the new features was that a single underscore is no longer valid as a variable name. So anybody here used underscore as a variable name? In Lambda? No? Okay, interesting. Well, you'll be happy to know that 2 or more underscores are still valid as variable names. So you can just expand on the number of underscores that you're using. But the idea behind that was that if you have a lambda expression and you've got multiple arguments in the lambda expression, you're not using all of them on in the body of the lambda expression, then you simply use the underscore to show that there is a variable there, but you don't care about it. So that was the idea of what they were doing with JEP 302. So we can apply that to our pattern matching and sort of using multiple ones together. And we can say if s instance of color rectangle, color point, point, var x, because that's the only one we're actually interested in, and then everything else we simply mark as an underscore. So the compiler knows that there is a variable in there, but it will match against it to make sure that everything is right in terms of the structure, but we don't even want to be able to like reference it or use it. So we simply mark it as an underscore, and then we can print out x. Now, obviously in this example, it's a very trivial example, so you probably wouldn't do this, but there is a real benefit to this in more complex code where you're using this in a more powerful way. So yes, so we have no interest in those variables, so we just ignore them. The next thing that we could also do with pattern matching is take this idea of deconstruction a little bit further, and we could do pattern matching for arrays. If we can do it for records, why not arrays? Let's say we do something like this. So we want to print the first 2 strings, and we pass in, again, just an object reference, and we say if O is an instance of an array of strings, and the length of that array is greater than or equal to 2, then let's take the first element of the array, the second element of the array, and then we'll print out the concatenation of those. Why not use pattern matching and say if O instance of string array, and then we'll use the same syntax that we use for defining an array of strings using the braces, and say string S1, string S2, we'll use the ellipsis to indicate that we've got a variable number of arguments and there could be more than 2 strings and we don't care about however many more there are, then we can print out S1 plus S2. Now this was going to be included in JEP 405, which is the record patterns, but for some reason they seem to have taken it out of that. I guess it will come at some point in the future. I'm not quite sure why they haven't done this. I think there's still some discussion about the syntax of this and the best way to make it work, but I would expect to see that come in at some point fairly soon. So to summarize then, I think it's fair to say that pattern matching is a powerful set of language constructs. There's a lot that we can do with pattern matching to ensure that we simplify a number of tasks. We can, get more declarative code, much less boilerplate code involved. And there's even some ability underneath, although it looks a lot like syntactic sugar most of the time, there's also the ability underneath in terms of the JVM to optimize for better performance and things like that. A lot of these features, as I said, they're already included up to JDK 18. You'll see some of these in like JDK 19, 20, and so on, and there may be even more beyond that. So just since I work for Azul, and since you're all sitting in front of me, I will just tell you a little bit about what we do. Who's heard of Azul before you came to this? Okay, so not everybody, that's good, okay? So I can educate people on what it is we do. So basically we do two things. We're all about Java runtimes. The first thing we do is just a straight build of OpenJDK. It's what we call Zulu or Azul Platform Core. In the same way that you get different distributions of Linux, so you've got Red Hat, you've got Ubuntu, you've got Debian or whoever, you can get different distributions of OpenJDK. There isn't really so much difference because we're all building from the same source code, and ideally you're going to get exactly the same thing as long as you're TCK tested. What we do is provide that for free. So if you want to, you can get builds for free for JDK 8, 11, 13, 15, 17. We also have 18 and early access versions of 19 that you can get from our website. We also provide commercial support around that. So it's very much the Red Hat model of saying if you want to use it and have somebody to call if there's a problem, make sure you get all the updates in a timely manner, then we do that for JDK 8, 11, 13, 15, 17, and we also do it for older versions, JDK 6 and JDK 7. And that we find there are still a lot of people who are using old versions. Anybody here using JDK 6 or JDK 7? Okay, that's good for you. That's very good for you. The other thing we do, which I'm going to have Tom just talk very briefly about, is our platform Prime. So Tom is my colleague who's the SE for West Coast, aren't you? Yeah.
Yeah. So actually, this is also my territory. So I represent both the core products prior to Azul and what they've been at. So I've been in enterprise open source for years prior to that. So long history of seeing the value in open source, but also the enterprise support for. So the Prime product is a commercial product that we do. So we're basically competing against ourselves, and we can compete against free, which we also do. So, but the commercial product is has its own garbage collector. The high performance lossless garbage collection is continuous. So it's much more efficient than the P1 GC or some of the other so, for example, we started doing this with Wall Street companies that were looking for ultra low latency down to the microsecond, and they couldn't tolerate any losses at all. And the other aspect that we do this is we regression test this extensively. So if we did a release and it's like a microsecond slower than the previous release, we'd be in big trouble. So that's part of the garbage collector that we do, and then we also do the C2 JIT compiler called Falcon, which is a super optimized JIT compiler. So it's a continuous JIT, which will continue to optimize our producer days or however long we're optimizing code. So we'll, over time, and based on your runtime code paths, find more optimal code for that code path. And then we have other ways to essentially cache that optimization to disk using the Ready Now capability. And then next time you start the instance, it basically starts from where you left off, so you don't have to get from scratch each time. And then finally, we also have found a way to take that JIT operation and put that into a separate JIT cloud. So your regular runtime code can just focus on operations 100%. And if it needs any JIT, you just go to the JIT cloud, grab code, and basically start at full performance from where it is any short line instance. Anyhow, nice things also is that it's ultra efficient. So when you're running in places like the cloud, facing large cloud bills, you can actually reduce the number of instances. We've seen anywhere from 50% up to potentially 80% reduction in your cloud footprint. and so essentially pays for itself. So I think these things kind of interesting. Enterprise for open for the core. We're much less expensive than Oracle, for example, or further efficiencies with commercial cloud.
Okay, and then I've just got one more slide. Oh, yeah, question.
I was curious, since we're talking about Azul, I know quite a while ago, Azul was doing some kind of a hardware with Java.
Yes.
And I'm curious whatever happened with that.
The Vega systems, yeah, that was before my time, but that was how the company actually got started, was that there were three co-founders, two of whom still work for the company. There's Scott, who's our CEO, and Gil, who's our real CTO, as opposed to the deputy CTO. And they started out with the idea that to do garbage collection efficiently, you needed lots and lots of threads. So they, at that time, because this was the early 2000s, we didn't have massive multi-core processors in those days. So they essentially, they came from Scott came from a chip design background. So they made their own multi-core, it's really like a GPU type of thing, specifically to do garbage collection in hardware. And they were reasonably successful with that. But of course, developing hardware and chip designs is very expensive, and getting it all fabricated and stuff like that. So after about 5 years, they made a pivot to doing a software-only solution, which is where Platform Prime, or Zing as it used to be called, came from. So that was how we kind of, the company evolved.
No, we're planning to like bring that back with like the cloud infrastructures now, or.
Yeah, I mean that's one of so with the idea of the cloud native compiler, that's sort of the idea is saying, okay, let's separate out the JIT compiler from the JVM. I mean, it's still there because obviously if you don't lose the network connection, you want to be able to do JIT compilation, but it's outsourcing it to a separate service in the cloud and taking advantage of the scale that you can get. And plus, if you've got a service running, then you can remember things. So next time you start up a JVM, you've already got code cached, and you can just deliver that straight away for the same application. And you can base that on all sorts of things like speculative optimizations and stuff like that. So there's lots of interesting stuff that we can do with that. Okay, so yeah, one last slide, which is my free offer. So we like coming and doing presentations to Java user groups, and obviously that's what we've done this evening. But we're very happy to do this for companies as well. So if you work for a company where you've got lots of Java developers, often companies do things like brown bag events, lunch and learn, that type of thing. If you're interested in a presentation which covers like the stuff that I've just talked about, other things to do with the Java platform in terms of the language development, anything that we're doing in terms of JVM performance, we can talk about that. The cloud native compiler. It's not a sales pitch. It's very technical. Help people understand what can be done to improve performance in Java applications, or like I say, Java language, all those kinds of things. So if you're interested in that, please feel free to contact me. Can't guarantee I'll be able to do it in person. Most of the time it would be a Zoom call type of thing. But you know, if you want something like that, we're very happy to do that. So that's it. So if you've got any questions other than the ones we've already answered, then very happy to take those.
So the switch statements you have that were detecting the types didn't have the instance of keyword.
That's right. Yeah.
Which kind of bothered me. I saw the switch and then just the variable name. Why is it because you have the type in that case statement then it's.
Yes. Yeah, because you're effectively doing it as a because in the instance of you're using the if statement. So you're doing if O instance of string S. So your predicate is O instance of string. Whereas in the switch statement or switch expression, we can simply do case. So that's effectively the if. We don't need to do the instance of because you're matching against the type. So, I mean, you could argue, yes, you could include an instance of there, but it avoids more boilerplate code. So just by saying that.
And you fix the type and your variable. Use like just using the regular switch, you're checking the value of case
Oh, I see. So you're saying, can you mix, so switch on O and then do case 1 and then also do case string S?
Yeah.
I don't think so, no. I haven't tried that. I think the problem well, I don't know. It might work if it's complete, but I think the default, no. I don't know. I would have to try that. Yeah. Yeah. True. Yes. Yeah. Yeah. You could do that. Yeah, because if you don't, although if I would have to try it because I can think of a situation where you could do switch on n where n is a number, and then you could do a case with a value. But would you be able to do that? No, I would have to try it to see whether it worked. I can't think through the logic of that at the moment.
Sort of a when should I use this tool type of question. So I see the value in this pattern matching with like types that I don't have control over, so I can't expand their interfaces, or the records. The records example makes sense to me. But when you were showing the example with the shapes, my first thought was there should just be an interface method on shape that the subclasses should implement. Like, why are we using case statements? So is there a case for using these case statements on types that I have defined and control? I don't see that case.
Yeah, I mean, I will agree with you, and in the sense that if I think about how often I would use something like this, because I don't often test types in that way, but obviously the developers have felt that there is a need for this, so they've included it. But yeah, I certainly agree with what you're saying there, in that when I think of all the code I've written, I've very rarely had a situation where I've taken a reference where I haven't known very much about the type, and I've had multiple if statements to test against a particular type. So yeah, it's probably one of the lesser used things. I think the record deconstruction pattern will be much more useful.
Yeah, that, or like if it's types that you don't
Yes.
fully interface for.
Yes.
Yeah. Okay.
So for record deconstruction, do you have to mention all of the?
Yes. Yes, because it has to match the.
You don't have that well, you were just speculating at that.
Yes. Yes. So right now you have to be completely explicit about the values in the record.
So
I
wanted the 12 out of 14. 12, then I can use your little.
Yes. Yeah. Yeah. Absolutely, you would. Yes.
Closure does something like that, right? Doesn't Closure have these deconstruction?
I've got to admit, I don't really know that much about Closure. Yeah. So.
JavaScript now structure.
You can pull it right out of the hash.
Mm-hmm.
Closure doesn't care about types, right?
Right.
Everything can be a hash math.
Yeah.
I have a question about writing now. So the sales pitch I heard was like when you restart, you remember like when the state that I was in. But whenever I restart something, it's either because there was a bug or I have new code. So I can't see the case of where I would just be restarting something and having want it to be the same state that it was when it got shut down.
Yeah, well, the use case is probably more like a production, like a daily use case, or even for that use case where you say you have more instances, and maybe the instances might be short lived. So, you know, you don't want to do the long, more of a cycle.
Okay.
Yeah.
We have an optimization statement as opposed to, it's not different variables.
Correct.
Yeah, it's just a code paths.
Exactly.
We have another research project, which is Java on Crack, and we might have to think about the naming of it. But it's what Crack stands for Coordinated Restore at Checkpoint. So this is the idea that you can run an application and then essentially create a snapshot of a running application, and then restart it at some point later, potentially on a different machine. So that's aimed much more at things like AWS Lambdas, where you've got very short-lived things that you want to start up instantly and not have to go through any class loading or a warm-up or anything like that. So it's sort of related to Ready now, but it's the idea of actually taking a snapshot of everything in all the variables, stack, heap, everything. So you can start from exactly the same point when you want to. But that, like I say, is a research project at the moment.
Well, I can see that, your question, I can see that being valuable in some of our services that have in-memory caches, that every time we restart, it has to repopulate that in-memory cache.
Yes.
Like that's problematic for us sometimes.
Yeah. And then, you know, in most cases, like the case of recompiling, there's still probably 90% or more of the so that's still valid. You just say the did and all that, and the one you have to read it, okay, but it's still working.
I had a question about the JCP process.
Yes, I am on the JCP executive committee, so yes, I should be able to answer that. And
So I know that, so you mentioned like one of the checks was kind of hold.
yeah,
Where that comes from. In my experience, front end world, browser vendors and JavaScript engines.
right.
And none of them, you know, if one of them decides to say, like if Mozilla says, I don't like this feature, it's not good for our hands, it's going to.
Yeah.
Then that would hinder the rollout.
Yes.
Now that like the OpenJDK and multiple different distributors, right? So like all the different versions of that, is that a similar sort of concern, or like how much of the delay is based around like, the different vendors have to get together?
Right. So the way that things work now is it used to be that everything was done through the JCP. So the standardization of Java was done through the Java community process, and each version of Java had a JEP. JDK, no, it had a JSR. I'm gonna get this right. 3-letter acronyms. So it had a JSR, which is Java Specification Request. And so if you look at the JCP, you'll see there's all the different JSRs for the different versions of Java. There is still that JSR at the moment. So we have a JSR for each version of Java. And again, so there's an expert group that forms around that. And I'm on the expert group. It involves none of my time. So there is nothing that I have to do. It's really just rubber stamping. All of the development of the Java platform now is done through the OpenJDK. And so you have these things called JEPs, JDK Enhancement Proposals. And JEPs are essentially, if you have committer status on the OpenJDK project, you can submit a JEP as an idea. Doesn't mean it will get in, but you can submit it as an idea. And so the way that things evolve is through these JEPs. But the sort of decisions about which JEPs go in is really controlled by Oracle. So they are the custodian, if you like, of Java. And they make the big decisions about which features go in and which features don't go in. So there isn't a sort of a problem, like you said, where different vendors have to get together. There's a goodly amount of discussion that happens on the aliases for OpenJDK. So even though Oracle are making the final decision, it isn't just, you know, they don't take any input from outside. So Amazon engineers, SAP engineers, Azul engineers, we all contribute sort of to these different things so that it's ultimately Oracle making the decision at the end of the day. So there isn't that same problem of different people trying to catch up, because then everybody just builds from the same OpenJDK source. So you know that when you get Ritter, it's the same as you get from Azul, it's the same as you get from Microsoft even. I mean, Microsoft doing their own version of Java, which kind of blows me away. So yeah, it's a little bit simpler than the browser world. Cool.
The whole phrase was.
Well, see, it used to be that the expert group actually used to meet and there would be discussions about which features should go into Java, and it was a very formal process. And that's gradually got less and less. We used to have phone call meetings, and then we said, well, there's nothing to talk about in phone call meetings, we just do it through email. And now we don't have email. It's just like, do you want to be on the expert group? Yes. And then next 6 months, do you want to be on the expert group? Yes. That's about all there is. It's more to do with the standardization and access to the intellectual property that's being contributed to the OpenJDK. It's just a legal sort of framework. Okay, thank you.